So far with the topic 8 stuff, where we left off, we did go through solving equations containing fractions. So it's making it look like solving equations gets a little bit more complex, but remember, if you will just have the first goal of what can I do to eliminate the denominator, then you're gonna be good. Yeah, no, I'm just kind of rehashing it. I always kind of review just a bit what we did. 8.6, we got started, but we didn't finish. So these are equations with fractions, right? But the difference is that we only have one fraction equaling another. So this is called a proportion. And so proportion is an equation that states that two ratios or rates are equal, basically. That's what it says right here. Proportions state that equality of two ratios or rates. Kind of says the same thing twice, it seems like. So you could multiply both sides by, like in this case, 20, right? Like we did in the other solving equations. But you're going to cross reduce, and basically a lot shorter way to think of it is to cross multiply, and I call it the butterfly method. It's a little bit easier when we have things like this in the denominator. Otherwise, you would have had to multiply both sides times x and x minus 2. And I try not to get all that deep in it because you're never going to have to really do that anyways. So if we can think one fraction equaling another, we're going to butterfly. It's going to make solving way easier. We skipped number 4 because it's kind of a special case. We do have to come back to it. But let's go to number 5. I think I told you to try 3 and 6 on your own at the end of class, but we only went back over 3. So you can cross multiply any direction you want first. So I'm going to work from my top left to my bottom right. So 3 times 2x plus 1 equals 4 times x minus 2. And so by cross multiplying, that would be the same as if, see how these two things have two different binomials in the bottom? Technically what's happening is you're saying you're multiplying both sides by it, and then this would cross out, leaving you with just the x minus 2. That's super busy. So we just do it this way, makes it way easier. So 3 times 2x is 6x, and 3 times 1 is 3. 4 times x is 4x, and 4 times a negative 2 is a negative 8. We have variables on both sides and constants on both. We're about to get to next week inequalities and why I like to keep my variable on the left. But I want to move my variable for x from the right to the left, and I do that by subtracting. So I have 6 minus 4 is 2x. Then I would bring down plus 3 equals, and remember this is a negative 8. So don't forget to bring down that minus sign. Then I would subtract 3, just squeeze it in there, but we'd have 2x equals a negative 8, and then negative 3 is a negative 11. To get x by itself, you would divide by 2. Please, please, please try to stay out of decimals. Had some questions lately about that. We don't turn things to decimals hardly ever. This one could turn to a decimal evenly and be ending, and it would probably be fine. But just leave it as an improper fraction. You're causing an extra step anyways, but like if that were 11 over 3, that could not divide evenly, and that decimal would go on and on. If you answer that as a decimal, I have to count it wrong, like on a quiz or a test, and WebAssign's going to count it wrong. So leave them as fractions. We're going to go to number 6. 5 times x plus 1 equals a negative 2 times 2x minus 3. So we will be distributing 5 times x is 5x. 5 times 1 is 5. Negative 2 times 2x is a negative 4x, and a negative 2 times a negative 3 is a positive 6. These are way easier, right? They look busy still, but if you're just cross multiplying, it's a lot easier than the types of problems we did over here. But again, remember, I couldn't cross multiply over here because like this had +2. So it's not just a fraction equaling a fraction, it had like a constant over there separated by it. So once you move that over, when we got here, we could have butterfly. And that's what I would encourage you to do. Once you learn to move it, then just butterfly it. Okay, so here we're gonna add 4x. So 9x, I'm gonna bring down my 5 and my 6. Then you're gonna subtract 5. We get 9x equals 1. What's my last step? Divide by 9. And we're gonna leave it as 1/9. We're not gonna divide and try to turn that into a decimal. Oh, number 4 is gonna be a special case that ends up happening. We'll end up doing this a lot, but we have to kind of remind you how to do some factoring before we ever review factoring. So I don't hit you with it a lot in this unit one, but I'm gonna go ahead and show it to you, okay? So if I cross multiplied and I took x times 5x, you guys remember what would happen there? Right, it's gonna make a 5x squared. Because x and x make that 2 of those, so x squared. And then I'm gonna take 5 times my x plus 2 on the other side. And so because of the squared right there, this right here, once we start moving stuff, but I just want to identify it right now before we even go, this means that this is a quadratic. Basically, that means you will have 2 x values, right? If you have x squared, there's 2 x values, not like 1, 2, 3, 5, and 6. There's only 1 x. So the first thing we need to do is distribute 5 times x is 5x, and 5 times 2 is a positive 10. When you have a quadratic, we need to have everything on the same side because we're going to have to factor it. Again, I don't expect you to totally know this, but we're introducing it now just a little bit, okay? So if I want everything on the same side, I would probably move everything to the left so I can keep my x squared term positive. So that would make it 5x squared minus 5x minus 10 equals, and this side zeroed out, right? See that? And so in algebra, you know, whether you loved it or not, you learned how to factor. It may have been a while since you've done it. Maybe you hated it, but I'm going to take you through it. Do you guys see anything in common in those 3 terms? Like, can they all be divided by something? 5. So we're going to factor out a 5 first. We're going to say, I don't want that 5 in front of those numbers, or, you know, I don't want that 5 there because I can divide it out. So I'm going to divide each one by 5. So you would just have an x squared, a minus 1x. Let me go ahead and put a 1 there. And a minus 2. I will double check our homework and make sure you don't have one quite like this in there. But I might give that to you for like a bonus or something. If you know how to do it or remember, you can go back over this problem. But we're going to set up 2 parentheses. And this is where you learn to factor. If this last term, we will spend a whole unit on this in the future. So we're not there. But because this last term is negative, I know I'm using opposite signs to make the middle term. If I take 2 times 1, that's 2, isn't it? If I want to make a negative 1 middle term, that means that would be a negative 2 and a positive 1. So I know you may not remember that. Don't freak out. Just showing you that in the future, we're going to have to be able to do that. And that's why solving equations is very important, because we continue to solve equations later. Okay, we'll spend a whole lecture on factoring. So we're just going to write x minus 2 and x plus 1. So my 2 values for x here we would get by taking each of those parentheses and set them equal to 0. And then we just solve. We could add 2 over here. So we would get x equals 2. And we would subtract 1 over here, which x equals -1. So technically, I probably should have blotted that problem out for you guys because we're not there yet. I thought you were okay with at least just seeing it and noticing the difference when you cross multiplied here. We ended up with an x squared, which makes it quadratic. We're not really working with quite yet. You will get there later, and it will go a little bit. You'll have to take those proportions a little bit further. Okay. So that's why I wrote special, quadratic, just something good. Those of you that remember it, cool. If you don't, that's also cool. So we have some word problems, and it makes it seem like I heard all of you, or a few of you, a couple of you say, I hate word problems. I did great, but I never had to do word problems. And I also hated word problems. Why? Because I just didn't want to read. That's really why. I didn't want to read the problem. But I'm going to try to show you a way that makes these really easy. These set up just like proportions. Okay, so when we read this, 2 pounds of cashews cost $5.80. At this rate, how much would 15 pounds of cashews cost? If you can just think, we're going to make a ratio between 2 pounds. Let's write 2, and I'll write pounds beside it because your units kind of matter in a minute. 2 pounds cost $5.80. If we make a rate or like a fraction out of it and set it equal to another fraction, what I want to tell you is make sure your units align. So in this case, I want to put pounds over money. Because we have 2 units, we're working with pounds of cashews and we're working with money, how much it costs, right? And so over here it says, at this rate, how much would 15 pounds cost? So you don't really have to think, you just know, well, pounds is at the top part of that other side. So I'm going to put pounds up there as well. How much does it cost is like my X. It's my unknown. So as long as you can keep it straight, what units you're working with, and you keep all of them, whatever's in the numerator, the same on the other side, I think you're going to set these word problems up easier than maybe you have in the past. Now we just cross multiply. We do our butterfly. So 2 times X is 2X. And 580 times 15. I'm going to just type it in my calculator. 15 times 580 is 87. Then we divide by 2. So 87 divided by 2 means X equals 43.50. Remember, they want to know how much did 15 pounds cost. So that's a dollar amount. In WebAssign, they'll already have the dollar there for you. But just think about what you were solving for. We were solving for the cost of it. Number 8 says a pre-election survey showed that 5 out of every 8 voters would vote in a special election. At this rate, how many people would be expected to vote in a city of 180,000? So we're talking about people. You can't just say people over people, right? You have 5 people that voted out of 8. Or sorry, 5 out of 8 voters. Okay. So I would put voted out of a total amount. So if you have like what I would say the same units, in this case people, it's probably a part out of a total, right? That's really what I meant to say. So 5 out of every 8 voters would vote in a special election. So say 8 of us are voters, but maybe it's a special election, maybe it's a school board election or something. What that's saying is maybe only 5 out of the 8 of you that usually vote may go vote for that. Okay, so we're gonna make that 5 out of 8, just like that. Now, wants to know in a special election at this rate, how many people would be expected to vote in a city of 180,000? So that would be like, you're saying 180,000 people, they could be voters, they're registered to vote. Maybe they don't always vote. So we want to know how many would vote, so that's up there. That makes sense to you? Question? Okay, so we're gonna cross multiply to solve. I like to try to pick up my letter first. I'm gonna do this diagonal first. So 8x equals my 5 times, it's gonna be a pretty big number, 5 times 180,000, which is 900,000. If we divide by 8, the I divide by 8. I wrote an extra 0. Five times 180,000 divided by 8. I think I just was not looking at it right. There we go. So what this means is 112,500 people voted. The proportions are setting two things that are related equally to and equal to each other. Think about fractions. You know, like when you had to find a common denominator to be able to add fractions, you had to make something bigger. That's kind of what that's doing, but you have an unknown and you're figuring that unknown, which might have been your numerator in a sense. I'm going to come back to 9 just because it reads kind of funky. It's probably the one that reads the funniest out of all of these examples. Let's go to number 10. 10 says a quality control inspector found 6 defective DVDs in the shipment of 4,000. At this rate, how many DVDs would be expected to be defective in a shipment of 10,000? So again, we're talking about DVDs. But what's separating the types of DVDs? Right. So I would put defective out of total. So again, a lot of times if you're using the same units like DVDs, you're gonna have something that separates it by the total. So a lot of times we also have 2 different units, but sometimes we have the same units, just represent something different. So I wrote that in the wrong spot, wrote it up here, but I'll have to scribble that out. Sorry. So we have 6 defective out of 4,000. And we want to know how many will be defective out of a shipment of 10,000. So if we cross multiply, we would get 4,000x equals 6 times 10,000 is 16,000. What do we do next? Divide. And you can use your calculator, or you can think about how the zeros reduce, and then you can divide littler numbers, or just reduce it, but x equals 15. 15 defective DVDs. See more, and I think we're gonna stop there today, actually. We may have 2 assignments due on Friday next week, but you could be working on this because you'll be able to do most of it. Just a little part that you won't be able to do. 11 says a caterer estimates that 3 gallons of coffee will serve 48 people. How much coffee is necessary to serve 144 people? So we're talking about gallons of coffee out of people that it serves. So see, I like to identify what am I even talking about? What are the units? So I have 3 gallons of coffee for every 48 people. So we make a ratio out of that. Fraction. How much coffee? So coffee's in the top. Do I need to serve 144 people? So isn't that easy? Like to solve those equations makes it way easier. I mean, compared to other methods that you may learn or whatever, but this is a lot easier in many ways, as long as you can identify units. So 48x equals 3 times 144, which is 432. Then we divide by 48. And you get 9. So that means we need 9 gallons of coffee to serve that many people. Last one we're going to do, I'm pretty sure, is one that you'll see on homework. I often use it on a quiz or a test as well. And I didn't skip it because it's hard. I'm just a very patterny person, and I like for it all to read the same until maybe the last one, where you can see things different. I can't show you every example that you'll ever see, but we can pick up on that pattern, and it can help us do other problems that could be worded a little different. So 9 says, in a wildlife preserve, 60 deer are captured, tagged, and then released. Later, 200 deer are examined, and 8 of them were found to have tags. Estimate the number of deer in the preserve. So this one just kind of reads what I say backwards, because we're used to being given the starter ratio first, which was in this case the second sentence. See how you have 2 numbers in that sentence? That's how you're making the ratio. So that's how you'll know if it reads kind of weird, like number 9. So it says later 200 deer are examined and 8 of them are found to have tags. So you could put total over tagged, or you could even go the other direction as long as your units are set up in a specific spot. But since it read 200 deer are examined, so that's total deer that got examined, right? 8 of those 200 were tagged, so I called those the tagged deer. So I'm going to write 200 over 8. And then we can go back to that first sentence. It says, in a wildlife preserve, 60 deer are captured, tagged, and then released. Estimate the number of deer in the preserve. So are we looking for the total or the tagged deer? The total. Good. I circled tag to try to also give you a good hint. This tells you they caught them, right? And they tagged them. And I don't think there's ever a way they're ever going to know exactly how many deer are in the preserve. Okay, but they use a ratio to estimate that. So we put X up here and 60 down here. And then we can cross multiply. So you guys go ahead and practice that on your own. I'm going to do it as well. I see most of you working, so that's good. So could you flip? Yes, you could do 8 over 200 as long as the other side was 60 over X. Which actually is how I might have done it, because I kind of like to see smaller numbers on top. But I like to see totals in the bottom. But they're saying that there's approximately, the ratio holds true. It's never going to be exact, but they would estimate if there's 1,500 deer in that preserve. So next time we meet, we are going to talk about literal equations. And this is, if you're getting started on your homework, this is where you can stop. Literal equations are equations that have more than just one letter. They might have an X and a Y, an X and a Z, an A, B, C, D, E, F, G. They'll have lots of letters. And we just use those principles of solving equations to rearrange them. We never find an actual value, we just rearrange them. Okay, so we'll learn that and our 2, 5 in the next class meeting. Okay, let's stop this recording.